Let's talk for just a minute about how we take two numbers in scientific notation and multiply them together or divide them. So let's start with multiplying. If we had one number, a times 10 to the b, and that's in scientific notation, and another number, c times 10 to the d, and that's in scientific notation, how do we multiply these two guys together? Well, the main thing to remember is even though we're using different symbols for times, they're all multiplication. This is multiplication, and this little X is the times symbol, and so is this one. And one thing we know about multiplication is that it's what we call commutative. In other words, it doesn't matter the order in which you multiply. 2 times 3 is the same thing as 3 times 2. Well, we're going to use that fact here. We have a times 10 to the b times c times 10 to the d. Let's group the a and the c together, and we'll take a times c, and then we'll take the 10 to the b and the 10 to the d and multiply those together. But since they have the same base, we actually know what that's going to equal. It would equal 10 to the b plus d. Like bases, you're going to add the exponents together if you're multiplying the terms together. And so this would be your answer. Now, there's only one thing you have to be careful about. If you remember, one of the criteria to be in scientific notation was that your a and your c had to only have ones digits or ones units or ones places. You couldn't have double digit numbers here. The a could be something like 7.2, but not 72, because you don't want a ones digit and a tens digit. And what often happens is you might have a number a that has a ones place and just a ones place, and a number c that has the same, but when you multiply them, it turns into a double digit number. For instance, you might have 3 and 4, which are both okay, but 3 times 4 makes 12. And so the thing we have to be careful about is this answer right here. You might need to put that back in scientific notation, because even though it might look like scientific notation, it may not exactly fit the criteria of being in scientific notation. You don't always have to do that, but sometimes you do. Let's try a quick example. Let's say we had 4.21 times 10 to the third, and we're going to multiply that by 7.8 times 10 to the ninth, right? Something like that. Well, then this answer would be, let's multiply these here. We'll get our calculator out. We'll take 4.21 times 7.8. So 4.21 times 7.8. So our leading number would be 32.838. 32.838. Now I know that's not exactly correct, or it's a final answer, and we'll fix this number in just a minute to make it 3.2838. We'll do that in just a minute. The tens will be, 10 to the third times 10 to the ninth would make 10 to the 12th. And this is almost your answer. This almost looks like it's in scientific notation. The only thing I don't really like is this 32.838. It seems like this should be it seems like it should only have a ones digit, not a ones digit and a tens digit. But it's no big deal. It's an easy fix. Let's bring this number up here. It's very clear what this leading a should be. It should be 3.2838. But if we're going to change the a, then the b, the times 10 to the b, that has to compensate for the change that we made. So let's think about this. We did have 10 to the 12th. Now what we just did was we made our a smaller, which means the times 10 to the b would have to work a little harder or be a little larger to make these numbers equivalent. So we would need times 10 to the 13th. And here's how I know that. To get this number not written in scientific notation, we'd have to move this decimal place 12 units to the right. We understand that. But because this one is one decimal place farther, we'd actually have to move him 13 places to the right. One place just to catch up with where it was, the 32.838, plus an additional 12. So if you have to adjust the decimal place to make your a look correct, then you're also going to have to adjust your exponent for 10 so that the numbers match up. So just be aware that you might have to put this guy back into scientific notation after you multiply. But basically you multiply the leading terms, and then you multiply the powers of 10 separately, and then you fix things when you're done. All right, division is actually quite similar. For division, what we can do is we can take the a divided by c to be one number, that'll be like your leading number, times 10 to the b minus d, because as you well know, if you have like bases, then you would subtract the exponents. The same thing is true that I said just a minute ago also. This a over c, if that's not between 1 and 10, if it doesn't just have a ones place, you might need to adjust the decimal place. So let's give this one a shot. Let's say we had 2.2 times 10 to the 15th divided by, let's see, 4.9 times 10 to the 10th, something like that. Well, then our answer, we would take 2.2 divided by 4.9, 2.2 divided by 4.9, and we would get 0.44, we'll say 0.44898, 0.44898, 0.44898 times 10 to the 5th. That's 10 to the 15th divided by 10 to the 10th. Well, now we just need to adjust this decimal place because this doesn't just have a ones unit or ones place. This would be better written as 4.4898. But now we have to think about this, and this takes a lot of thinking. You have to think very carefully about this. If this number, if I made it larger, then I would actually have to decrease this exponent by 1. In other words, moving this decimal place right 5 places would be the same as moving this decimal place right only 4 places, because it's already been moved once to the right and I only have 4 more to go. So this would be your final answer in scientific notation. Now you might be asking yourself, you might say, well, Devin, we had to use our calculator a little bit for this stuff, the a divided by c or a times c. Is there a way just to do all this on the calculator? And actually there is, but I wanted to show you this way by hand first. In the next video, we'll talk specifically about how to do scientific notation and operations with scientific notation, specifically in the calculator.